We today are starting our last section of new material. It's a 2-day section, like we said, but this is the last new material, section 14.5. Can you believe we're almost done? And if you took all 3 semesters of your math at this point, which maybe you have, maybe you haven't, you will have just about finished this whole book. And that doesn't happen in most math classes either. I mean, it takes us 3 semesters to get through this whole book. So hopefully you've gotten your money's worth out of it with it being 3 semesters long. So we're going to start today with volume. We're going to get about halfway through is our goal, and then we're going to do our group work from 14.4. Sound good? All right, so we'll start with volume. So volume is the number of cubic units needed to fill a 3-dimensional surface. A cubic unit is the amount of space taken up by a cube with a measure of 1 unit on each side. I always like to be able to give you reference points of where you see this in curriculums these days. And I have the benefit of having children in elementary school, so I can kind of give you some perspective, at least from the curriculums that they use. My son is doing this in 3rd grade right now. This is 3rd grade material, and I don't know that I would have known that about a week ago, that for sure that's where they hit it, but he brought stuff home, and he did not understand volume. Did not know the difference between volume and areas, so we had to have a talk. I actually didn't have the talk. My husband did because he caught it, but yeah, so this is about 3rd grade. So we're going to take a look at finding the difference between volume and surface area of some shapes that really are cubes. So obviously we would eventually move into shapes that maybe aren't cubic in nature, but these are all cubes that are sort of stuck together. And you can imagine, I hope, taking physical manipulatives and allowing kids to build this object and to turn it around and to count things. Can you picture that in your head? And that would be a super simple, easy activity because Legos are not that expensive. And they have other manipulatives, of course, that are very similar to that. But this is imagine Legos that are stuck on each other and they're forming these kinds of cubes. So this one says find the volume surface area. Let's start with volume. Volume is actually easier to find than surface area. I know we did surface area last time, but volume is counting the actual cubes space-wise in 3 dimensions that we have. How many cubes do you have here? There are 4. And because we don't have any units, we'll just say units cubed like this. Okay, so cubic units written that way. Surface area is usually where all of us have more difficulty. It's where having the object in our hands and being able to turn it around and look at it from different perspectives, it actually would be helpful. So if you have difficulty sort of 3-dimensionalizing this, you're not alone. There are more people that have that problem than you might imagine. So our picture right here is nicely perspective-wise done by looking from the front and the back, which will be the same of this object, from the left and the right, which the object's view from the left and the right should be the same, and from the top and the bottom. So if you think about those 3 viewpoints, because it's really 3, because the front looks the same as the back. So it's a 2-dimensional front view. So if you're looking at this object from the front, how many squares do you see? 4. And if you were to turn it around and look from the back, you would also see those same 4. So they're going to come to us, if you will, in pairs. So we have from the front, whoops, I meant to do that in white. From the front, there are 4. So this is my front back view. That's why there's 2 of them. There's 2 in terms of 2 from the left and the right. So if you were to turn this object to the left or to the right, how many cubes, or squares at that point, do you see? 2. You're seeing sort of the height of the particular 3-dimensional object we have. There's actually 2. And then we are going to look, from the top and the bottom. Okay, so if you imagine picking it up and looking underneath it, or if you imagine hovering in the sky above the object, how many squares, how many faces will you see from the top or from the bottom? 3. All right, we're going to multiply, we're going to add these up, and what will we get? What'd you get, Alicia?
I got 18.
18. Do we got a second on that? Yeah, it's 18. So it's 18 square units. It's square because we're looking at two-dimensional surfaces. Surface area is still square, it's because it's area. The volume is going to be cubed because it's space. Okay, so we're going to do the same thing, but with a little bit more difficult to look at images. So these are my images. This is how they show up. I don't know if, like my printout, apparently I printed this out at some point when I was #1 at home and #2 running out of colored ink, so my cubes look really funny. But yeah, they're very colorful, almost like rainbow-like. But as we're looking at these, again, we're going to try to do the same thing. Front and back, those match. Left and right, those match top and bottom. So sometimes it's easier, depending on how the perspective is drawn of the image, to sort of turn it to the right. And sometimes it might be easier for your perspective for you to think about it from the left. It doesn't matter. You'll get the same thing either way. So we have two images. One is I, and the other one is double I. And we are going to find two things for each one. The volume, again, that's usually the easier one to calculate, and then the surface area. So with our first object, what is the volume of that first object? And we're assuming there are no boxes that are like hiding and not there, right? So like if you're looking at this object, sorry, I was looking at the wrong one on my screen. You're assuming that underneath this one in the back corner, there's a box. Like I don't see it, but I'm assuming that there's not just a hole that I can't see. Okay, so there's no sort of hiding holes. No hidey holes for the children to hide in, okay? That's not what we got going on. So how many cubes are there that you expect to be in this particular object? I think there's 9. So let's double check to count here. I've got 1, 2, 3 here. I've got 4 here. There's 2 that are hiding at the back, 5 and 6. And then here's, here's 7, here's 8, and here's 9. Is everybody good with where I'm getting 9? Okay. So we do, in fact, intend that there are 9 cubic units here. Okay, so thinking again, we'll do it in the same order, front and back first. So from the front, and it's from the front and a little bit from this side because of the perspective and how it's drawn. So you're looking at it sort of from where Tori is sitting in the classroom this way. Are you guys with me on what the front is when I'm referencing this? Okay, so what from the front, how many surfaces, how many faces do you see? I see 6 as well. Is everybody good with 6? Okay, great. So there are 6, so this is 2 times 6, that's front and back. The next one that I did on the previous one was left and right. So if I look at it from the left or from the right, how many do you see? How many? 5? Did anybody see anything differently that we need to talk? Okay, 5 is what I see as well. So 2 times 5. And then how about from the top and the bottom? Do we have 6? Okay, fabulous. I like to say, and it is actually true, although I've definitely gotten better with it over time, that spatial skills are not my thing. I don't have spatial reasoning. At least it's not as good as some people's. This is the reason why it took me so long to figure out how to load the dishwasher properly. And I mean properly as in to get the most you can get in it, right? In an organized fashion, of course. This is the reason my husband always loaded the U-Haul trucks, because he could fit so much more inside that U-Haul truck, because he spatially reasons so much better. So if you're looking at this and you're hearing people answer really quickly, you may be more along the lines of like me, where it just takes you a minute to figure out what you're seeing, all right? What do you get when you add all this together? 34 is right. 34 square units. Again, square because we're doing area. Okay, let's give everybody an opportunity to look then at their third object like this. It's a little bit different because it sort of has this, like a hole, sort of a little bit in it, right? There is a dip in it, so it's kind of like it has a caving feature. But I would like for you to find the volume and then calculate what you believe the surface area to be, and then we'll double check and make sure that we have the same things. Okay, so let's just double check what our answers are. What did you get for your answer for volume? 9. Did anybody get anything different than 9? Okay, cool. 9 is what I have written down as well. So 9 units cubed, or cubic units, sounds good. How about surface area? What do we get? 36. Anything different? I actually have 37. Did anybody get 37? Okay, let's double check and see what happens, because there is something odd that happens here that hasn't happened before because of the caving feature. That caving feature does create something a little bit weird. So we'll see. I still may not have it written down right, but we'll see if we can see the difference between this object and something else. If we're looking from the top down, how many do we have? 6. So that would be the 2 times 6 like we did before. If we look from the left hand or the right hand side, what do we see? 5. Looks good. What about if we look from the top down or the bottom up? 6. So I have 2 times 6. Now, why is that not all of our sides in this particular picture? Do you know why? There's a side in the middle. Did you catch that side in the middle? Okay. I have a number written down here that I don't agree with. This is notes from before. But it didn't catch, shouldn't have caught this side right here, because if you looked from the left or the right, you didn't see that one, right? Everybody agree with that? It was hidden. I mean, you couldn't see that from view, and it's actually part of our surface area, like if we were wrapping newspaper around this or whatever. And back over here, I can't draw the box, but it's the box that would be on the other side of this. You couldn't see that piece either. So I think there's 2 more. I think I have that written down wrong in my notes. Does that sum give us the 36 that you had, Alicia? It does? Okay, fantastic. I'm going to fix my notes. So this is 36 square units. Cool. All right, some measures of volume to give you some perspective. You know, most of the time when we think of volume, we're thinking of the liquid measurements that we were dealing with. That's what we did, you know, with liters when we did the metric activity. Or you might think of liquid measurements that you drink in that are not metric, like what, ounces, gallons or pints or cups, things like that. You might think of those. However, what we've just defined volume to be is in terms of lengths and widths, right? So that's sort of a different perspective than what we were just talking about with those other liquid measurements. So some comparisons that sort of move us in between those 2 viewpoints. Clearly, the cubic foot, the cubic yard are things we've seen before with feet and yards. We can multiply the feet out, you know, with 12 inches 3 times to get the 1728. We can multiply the 3 feet in a yard out 3 times to get the 27 cubic feet. And then there's some ones down here that maybe you wouldn't have expected or you wouldn't have known. A gallon would be 231 cubic inches, a quart, a pint, a cup, a fluid ounce, these sorts of things. Now, most of these I think are written, are all these written on your table already? Are they? Good. And on the side of your table, you actually, or beside your table, do you actually have the little guy? How many of you have seen that guy before? Or something like him? Has everybody seen them before? No? I had not seen him before until I was older, actually. It's not something I remember from growing up. Usually they call this gallon guy. And so gallon guy is pretty cool. Gallon guy in the middle, let me just explain what you see. The purple in the middle is a gallon. And this is actually telling you that his 2 shoulders and his 2 quads or whatever, those would be quarts. And so there's 4 quarts in 1 gallon. So 1 gallon's the body, there's the 4 quarts. And then you can divvy things up after that. So notice right here, you have the 2 yellow pieces. Those are pints. There's 2 pints then and a quart. And then in each one of those pints, they break it down further, and there's 2 cups in each pint. So this is a super cool visual, and I think it's at the end of this. Nope, it's right here. I wanted to show you a real life like example. This is not gal and guy because obviously it's got a bow in its hair. This is gal and gal. This is from, I thought it was 4th grade, but I'm thinking now it's probably 3rd grade from my daughter when she was younger. And they created these in her math class. Super creative thing. Do you think that she might remember the conversions because she created this a bit better? I think that she would. These decorated the walls of the classroom when she was in that grade, and it's in one of her artwork books that we still have at home. So a lot of fun, a great visual aid for children. So metric units are still nicer in terms of conversions than our English units. Our metric units for volume, to compare the distance unit with the liquid unit, we have 1 cubic centimeter is the same thing as 1,000 cubic milliliters, or millimeters, of course, and that is 1 milliliter. Okay, not millimeter, milliliter. Okay, it's converting into that liquid measurement, and you can go down the list and see the equivalencies further down. This list is pretty helpful. When we get to our review day, we'll talk. You've had like tons of conversion lists. You've had tons of formulas. And we need to talk about what it is you actually need in terms of what you should put on a note card. Because if I told you to put everything on a note card, you don't have space for all these charts. It's not a practical statement. So we'll talk when we do review on Wednesday next week. It is Wednesday, right, that we're doing that on? Right? I think that's right. We'll talk on Wednesday about what the test looks like in terms of what do you need to write down for conversions. But this is our metric conversion. So we're going to spend some time doing some conversions. And we're going to start with, and remember, some of these conversions have more than one way to do them. So if I'm led in one direction and you're led in one direction, as long as we end up at the same answer, we're probably both doing the right thing. And I say probably because sometimes you can screw up multiple times and still end up at the right answer, right? I mean, it does happen, but it's not often. All right, so let's take an example. We've got 4.6 cubic meters. So looking at these two tables, and I'll let you tell me what to do, and we'll see if it works, and then I'll just make sure I'm converted and get the same answer as what I've got written down. What conversion would you like to make in terms of the 4.6 meters? And I am going to do these with the dimensional analysis, because even if I'm working inside of the metric, you notice this is going from cubic meters into liters. It's not just a decimal moving things over all the time, even in the metric system. So double checking on that. What do you notice? Oh, that says cubic meters. You just didn't see the 3. What do you notice that you might want to convert to? A relationship between cubic meters and liters. Do you see one that's helpful?
Convert it to decimeters or
Oops.
centimeters. Yeah.
So we've got these options here, right? Which one do you want to convert to? Centimeters? Okay, so this would be 1 million cubic centimeters. That's what that number is, correct? Yes? Okay. So if you're doing this, you're going to be thinking you've got 1 cubic meter, and this is 1 million cubic centimeters. Okay, I'm not where I need to be yet. I need to be in liters.
I'm starting to regret the centimeter decision.
So 1,000 cubic centimeters.
Yeah, right here's a really nice version, isn't it? 1,000 cubic centimeters is 1 liter. So 1,000 cubic centimeters is 1 liter. So the cubic centimeters canceled, which was the goal. The cubic meters canceled. I do have liters on this problem, but we just need to figure out what we actually have. Now, you can use your calculator to simplify all of it. You could also recognize that when you divide by powers of 10, like this 1,000, we'll cancel the 3 zeros right here. I mean, you're actually going to get that happening as well. So what would you get when you multiply 4.6 times 1,000?
4,600.
Yeah, 4,600 is right. So this is 4,600 or 4,600 liters. B is easier. Why is B easier than the one we just did? What's that?
Do we have it?
I can't hear you. I'm sorry, Casey.
Because we have a. I don't know.
Okay.
We're not going from liquids to solids.
Yeah, I mean, that's kind of the basic idea, right? We're not doing from a meter comparison, which is what we did before, whether it's meters or centimeters, but meters into liters. We're not changing bases. Yeah, that's a good way to describe it. We're not changing bases. These are both bases that are meters, correct? That's why it makes it easier. I don't have to worry about changing bases as well as changing the prefix of my base. This is just changing prefixes. So I've got this this list. King Henry died by drinking chocolate milk, and I'm going from millimeters cubed, which is right here, to decimeters cubed, which is right here. So how many decimal places am I moving? And if it were just single lengths, 2.
Oh, yeah.
1, 2. I'm just moving 2 if it's length, right? But it's not length, it's cubed. So I multiply by 3. So I'm moving 2 3 times. So my decimal started out as 365. Is the decimal moving left or is it moving right?
Left.
Left. How come, Alicia?
Because on the list, that's the direction.
Yeah, I moved left on my list, right? Left is left. That's good. So the decimal point starts out here. I need to move 6 decimal points. 1, 2, 3. Well, that's 3. And then I'm going to need 3 more zeros in order to make this work at the beginning to give me 3 more. So we have our decimal point, 3 zeros, and then 365. Okay? We did that when we did cubic or square units as well, right? It doubled the moves. Now we're doing cubic units, we're tripling the moves. All right, cubic inches and cubic yards. Well, they're both length measurements that we're cubing, right? That's good. Any thoughts as to what kind of a conversion you might like to make? There's more than one possibility here. Which ones were we going between? Yeah, I think that's what I would do too. So do you want to tell me what you're thinking in terms of your numbers? You said inches to feet and then feet to yards. Is that what you had, Alicia? Yeah, I think that sounds good. So what's the comparison? These are all cubic. What's the comparison between cubic feet and cubic inches? Did you have one?
728 inches.
Yeah, 1 cubic foot is 1728 cubic inches. If you were just doing simple, right, like linear measurements, no cubes, what would be the comparison between inches and feet? 12, 1 to 12, right? I would have 1 foot to 12 inches, agreed? So you can also just cube those if you would like, instead of using some of these tables that sort of make the problems harder, I think, than they make them easier. I like 12 cubed. I'm good with that. 1728, it's okay. How about the conversion between yards and feet? Just think yards and feet for a moment. What's the comparison? Yeah, it'd be 3 feet is 1 yard, right? And then again, you can cube the numbers. What's 3 cubed? It's 27. I just want to make sure nobody told me 9. Okay, good. All right, so I have my, whoops, thought that was a block pen, cubic. There's my cubic feet canceling, and then here's my cubic inches canceling. And so I can multiply across if I'd like. So I've got 874 across the top. Across the bottom I have 12 cubed, and I have 3 cubed, or 27. So what do you get if you multiply the numbers across the bottom and then take the number on top and divide? Does anybody have it? We'll approximate. What'd you get? If we use 2 decimal places, is that what you mean? Yeah. Yeah, so 0.02. What are we working in? Cubic yards at that point, right? Everybody good with that? Nice. All right, we got a couple more conversions. Find each of the following equivalencies: 37 gallons, something cubic feet. So how do we convert between gallons and feet? That is not a direct comparison that we've had till now, right? Because the liquid measurement of 37 gallons and cubic feet, that's a little different.
So gallons to inches and inches to feet.
Sure, sounds good. What do you have written down for gallons to inches?
231 inches to 1 gallon.
Okay, good. Now we're in, was it inches cubed? Okay, good. And then we need to go from inches to feet. Again, you can use the conversion numbers they use. It's not going to hurt anything, but you would also remember that 1 foot is the same as 12 inches. And of course, then we're cubing things like this. So my cubic inches, my gallons, I need 37 times 231. Divided by, it's, I guess we decided it's 1728, right? 2 decimal places, what do we have? 4.95 sounds good. And the last one we're going to look at is 97 cups. And we're turning that into inches. So thoughts, how would you like to turn your cups into inches? Cubic inches. I don't see any on that chart.
Can we do fluid ounces to gallons to inches?
Fluid ounces.
Can we do?
I think you mean, we're starting with gallons, so do you mean gallons to
we're
fluid
starting
ounces?
with-
Yeah.
Oh, yeah.
And then
Reverse everything.
fluid ounces to, what'd you say next?
Cup, wait. Okay, well, I don't know. I did it backwards. So that
Okay.
would be totally wrong.
Another suggestion then? Number of cubic inches more than. How about we turn it into gallons? It doesn't write it exactly like this, but right here in the middle here, well, actually it does, it's right there. Never mind, it's right here. Here's a cubic inches to gallons measurement, correct? Can I take my cups into gallons? Sure can. My cups into gallons, I don't even know if it's written here, but here's my little guy. How many cups are there in 1 gallon according to the gallon guy?
16.
There's 16. I don't know if you ever buy or look at the milk jugs in the cafeteria, but you can actually see what serving size. There's 16 servings inside a container of milk. Did you know that you're supposed to just drink 1/16 of that when you drink milk? It's not very much. Okay, so we have our cups to gallons. And we mentioned that that's 16 cups to 1 gallon, which is correct. And then the conversion from gallons into cubic inches was what? 1 gallon to what? 231. So let's do 97 times 231 divided by 16. What do you get? With 2 decimals. Yep, that's right. Good job. Okay, any questions on that? All right, we're going to pause there today that we have time to do your group work. Some of the other things we do later hopefully will move a little more quickly.